Hi again, it's Miss Borcherding. I'm coming here with the second set of notes for Unit 2. Again, if you guys have any feedback of what can make it better, just send me an email, let me know. I'm going to try to talk louder on this one, so hopefully that works, and hopefully the pen is not quite as loud. So I told you I'd put a picture in this time. So this is London. This is my favorite little outfit there, but so on to our notes, but just thought I'd show you that. So still dealing with transformations, okay, so a change in the shape, how it's laid out on the graph can be different things. Last time we looked at translation, which is a slide, okay, just sliding the shape from one place to another on the graph, and we looked at a reflection, so flipping it. So today we're going to look at rotations and dilations, start to get into symmetry a little bit. So a rotation is a turning. Oh, I'm going to turn my pen on. Just a minute. Okay, sorry. So turning a shape on the graph either clockwise so think, the way a clock turns like this, or counterclockwise. So the opposite way, okay? Like that. It's usually going to be either turning by 90 degrees, 180, or 270, okay? All right, so I don't know if I'm gonna have a whole lot of space in here, so hopefully I can fit this, but I'm gonna show you kind of the mapping, kind of the little cheat sheet of if you are turning it, which direction and how many degrees and what that does to your X and Y coordinates, okay? So you wanna think, first of all, each quadrant of the graph is 90 degrees. So if you're turning it 90 degrees, you're flipping it into the next quadrant, okay? So first one, I'm gonna put if rotated. And I'm trying to write in cursive so I'm not tapping the screen as much, so sorry if it's a little messy. So if it is rotated 90 degrees, I'm going to put CW for clockwise, all right? So that takes your X and Y coordinate, and what it does is you're flipping the X and Y values, okay? So Y is now whatever Y's value, so if Y was 5, the X value is now 5. So I'm putting Y to the front, X to the back, and you'll also make X its opposite. So I'm going to write what that looks like in the mapping diagram, and then in words what that means. So flip and make X opposite. Okay, now 90 degrees counterclockwise. So our rule or our mapping diagram start off with X comma Y. All right, then again, since it's a turn, we are flipping X and Y. So Y comes to the front, but Y is also going to be its opposite. Sorry. Flip X and Y and make Y opposite. Now 180 degrees, and this doesn't, this can kind of be either direction, so x comma y changes both of them. That's going to be negative x and negative y. So it doesn't flip them though. And the other one I mentioned was the 270 degrees. So this is either going to be the same as 90 degrees clockwise or 90 degrees counterclockwise. So you want to look at that and think. So 270 is 3 quadrants, okay? So see which direction that would be based on that problem, right? So same as either 90 degrees clockwise or 90 counterclockwise. I'm just going to write over here, each 90 degrees is a quadrant. So if that helps you kind of visualize how far that's moving or where that's moving to. Okay, so now getting into the actual rotation. So rotate triangle RSQ 90 degrees clockwise about the origin. So that just means the origin is like, so that's our middle point, right? If that was basically the center, and that's how you're spinning it based on that. So like if this were a clock, the origin would be the center where the arms meet, okay? So first thing always with transformations is write out your points that you have now, okay? This has to be accurate every time. So if you count wrong, your whole problem is wrong. So make sure you double check this, that you are 100% positive that those are the coordinates for those points, okay? So we have R is 1, 5. S is 4, 2. And Q is 2, 1. So again, double check them, make sure those are right. All right, and so here our clue, here are our rule. So 90 degrees clockwise. So what that tells me is, look up at the top here, look at our rule. So right here is what we're using. So I'm flipping the variables and I'm making x the opposite after I flipped it, okay? So let me show you what I mean here by that. So for R is 1, 5 currently, okay? So 1, 5. All right, if I'm transforming it using that rule, that means 5 and 1 flip, but I also have this negative on there, which makes the 1 become negative. All right, and that is my new R value. So down here, 5, negative 1. Okay, so go ahead and plot that. That's R prime, sorry. So 1, 2, 3, 4, 5, negative 1, R prime. All right, now S. So S prime. So again, flip my values, X and Y, so that's 2, 4. Same rule here, so I'm making that new Y, but the old X negative. So that's 2, negative 4. 1, 2, 1, 2, 3, 4. S prime. All right, and lastly Q prime. So flip 1 and 2, make 2 negative. So that last one, and remember if it were already negative, that would make it positive. So 1, negative 2, and I plot that as Q prime. Always connect them and see if it looks congruent. So a translation, a rotation, reflection, Okay, those are not changing the actual size of the shape. So make sure at the end, once you've drawn it, still looks congruent, still looks like a triangle. If it was a triangle before, okay, it doesn't change everything, just its location. And that one looks pretty close to our starting point, so that's a good indicator, right? And another thing to double check, it was 90 degrees clockwise. So 90 is one quadrant, so I moved one quadrant, and I did go in the clockwise direction. So remember, counter would have been the opposite. Okay, 2, we have the same coordinates, so 1, 5, 4, 2, and 2, 1, but we are doing 90 degrees counterclockwise, all right? And what makes that a little bit different is looking up here, instead of, only thing that's different really, you're flipping your X and Y still, okay? You're turning, anytime you're doing a rotation, you're turning, we're flipping those for our 90 degrees, but the Y, or the new X, will become negative, okay? So again, I'll do an example with R. So if R was 1, 5, okay, I flip those. Sorry. Let me erase that for a sec. Okay. Flip those, and then the new X that was our Y becomes negative. So this is now our prime. So I'll write that down here. Negative 5, 1. And plot it. 1, 2, 3, 4, 5. Positive 1. R prime. Okay. S prime. So and actually let's take a sec here. Why don't you go ahead and pause and see if you can find S and Q now using that mapping rule. So pause your video, try that on your own. Okay, if you have paused, so you should have flipped those. So S became 2, 4, make the 2 negative. And plot that. And lastly, Q prime. So I flip 1 and 2, make 1 negative. Connect your points. Check if they look congruent. Look pretty close. So. Okay, hold on. Having some issues here. Okay, so I got this a little bit cut off, but I can just read it online and go from there. So number 3 says rotate triangle RSQ 180 degrees about the origin. So 180 is going to be 2 quadrants, all right? So I'm dealing with those same points. Those have not changed. But 180 degrees tells us that we need to make, we're not flipping X and Y, but we are making X and Y both their opposite. So I'll do an example with R. So R was 1, 5. So my mapping rule says XY then becomes negative X, negative Y. Okay, so that means 1, 5. Now becomes R prime, which makes it negative 1, negative 5, all right? And that's all for that one, and I will plot that too. Okay, again, take a second, pause the video, and find S and Q using that same mapping rule up there. Okay, if you paused, you should be checking your answer now, not just writing down what I have. Okay, so S prime, should have became -4, -2. Oops. And Q prime should become -2, -1. Okay, 1, 2, 1. A little bit messy here, but again, so check, make sure it looks congruent, should match up if so, and write those down here. All right, and then number 4 here, so rotate quadrilateral, which just means a 4-sided shape, RSPQ 270 degrees clockwise about the origin. So this is where we kind of have to stop and think about that. Is it the same as 90 clockwise or 90 counterclockwise? So if we started this shape, okay, and we went 90 clockwise, that would take us from quadrant 1, or this quadrant, that's not 1, but into this quadrant, all right? And that's not 270 degrees, right? If we did 90, so 90 counterclockwise would put it over here. So let's see, so let's think about now which of those matches up with 270 clockwise. So if we're here, I go 90 degrees clockwise, another 90 degrees clockwise, and another 90 degrees. So that puts us in this same space as going the 90 counterclockwise. All right, so what I want to do there then, take that off, is I want to look and think about the 90 counterclockwise rule. So I'll write that up here. So, and you have it at the top of your notes. So XY then becomes they flip Y comma X with your Y being negative. Okay, so same thing as what we're going to do here. We do have different coordinates on this one, so why don't you take a minute, pause, and just write out the coordinates for PQRS. Okay, you should have gotten R is 1, 3. S is -2, -1. P is -3, 1. And Q is -1, 5. Okay, so I'm going to use that mapping rule up here, right here. And I'll start with R, and then we'll do like we did before. I'll do R, and you guys can do the others. So R, 1, 3, going to transform to R prime. So I'm flipping X and Y, and I'm making the new X, the old Y, negative, or its opposite. So that gives me -3, 1. Okay, so go ahead and pause the video, see if you can find S, P, and Q. Okay, if you did those correctly, so I'm going to show you S real quick actually just to make sure you guys are good. So S was -2, -1, and then we transform that to S prime, which, so we flip those, so that's -1, -2 just from flipping them. But since we're making that new X negative, it's also making it opposite. So if it's negative now, you should have +1, -2 for S. Okay, P, you should have gotten -1, -3. And for Q, you should have gotten -5, -1. Okay, so just to kind of sum up our points, you write out the points first. Okay, find your new coordinates, and then graph those new coordinates. So I'm going to do that now. So R is actually now, R prime is where P used to be. So right there, I'm sharing that point. Okay, S. P. And Q. Always connect them. It's hard to tell if they're congruent if they're not connected, okay? So then look and kind of see, does that look pretty accurate? My drawing is not the best, but it is still pretty close, all right? Okay, if you ever get stuck on rotations, one thing that can really help you, especially if you're not sure about the mapping diagram part, like maybe you forget which one you're flipping or which one becomes negative, okay? Best thing to do to help you visualize this is, and I want you to write this down here too, rotate your paper. Okay, so this will help you kind of visualize and see where it should be. So like 90 degrees clockwise. So take your paper, turn it one quadrant, okay, going clockwise, and then pretend that's where your graph were then and count those coordinates, okay? It's kind of hard to show you that on a video, but hopefully you can kind of get what I mean. So turn your paper, pretend that's how your graph was, and get those coordinates from there, okay? All right, moving on to our next page here. I don't know why it keeps sliding up when I do that. Okay, sorry, I couldn't get to scroll, but so the next part of your notes for today are dilations. So a dilation is actually a change in size. So reflections, transformations, and rotations all ended with a congruent shape because they were the same size, they were just in a different location, all right? Like if I take a soda can and I move it to another location, it's still the same size soda, it's just in a different spot, okay? Dilation is where you're actually changing that size, all right? Maybe you took a water bottle and you heated it and shrunk it down. Well, it's no longer congruent because it's a different size, okay? So dilations change the size of a shape by stretching, sorry, or shrinking it. Okay, so bigger or smaller. Okay, scale factor, this is, so if you think like if something's drawn to scale, like think architectural drawings or something, okay? That is the ratio that's used to create that drawing or that different sizing, all right? Like how many inches on that paper represent how many feet in real life if you're looking at architectural drawings, okay? So here we're thinking, so it's that ratio, that number they used. So the ratio used to dilate a figure all right, and there's kind of two things to think here. If the number is greater than 1, you will get a larger shape. You think like double something, all right? 2 is greater than 1, so you're doubling it, you're making it 2 times as big. If it is less than 1, so maybe it's half the size, okay? You're getting a smaller shape. All right, and then to find the scale factor, you're going to take your new coordinate actually, let me write this a little different so there's room. So new coordinate and you divide by the old coordinate. And I'll show you what I mean on that here in a minute, but so you have this for reference. All right, point notation or mapping rule. So this is like your x comma y part. So if it looks like this, let's say, and this is just an example. So if that's your original coordinate, and then it said, let's say 3x and 3y. That just means they took 3 times the original x value, 3 times the y value to get the new coordinates. This is always going to be multiplication for dilation. So multiply each coordinate by the scale factor, which we found previously, or should have, in each problem. Okay? So I'm going to go on to the actual questions. Okay, 5. Identify the scale factor used. So basically there are a lot of ways you could do this one. You have your original here. You do need to make sure you know the difference in the original or the pre-image and the new image. So how we tell that is our original is these ones without the apostrophe or the prime. All right, so those are our originals, and that's important to know that. Okay, so I can pick any one of these points. It doesn't matter. E, D, C, F, any of them. Okay, and what we're going to do, so I'm going to pick, actually I'll write 2 of them and then I'll show you why I'm picking that. So let's say, so C, its current coordinates are 1, -3. That is this C right here. Okay. C prime, okay, is 1.5, and that's where this is like in the middle here. So 1.5 there, and then if I look there, -4.5. Okay. Now D, original D would have been this one. So 2, -1. And now D prime, so looking at this one, is 3, -1.5. Okay, so like I said, you can use any 2 or any point. It doesn't matter which one, as long as, like, I can't pick C and D. I can't put those together. They need to be the ones that correlate to each other, those same, like D and D prime. So the same point, it's just before dilation, after dilation, okay? I also only need to pick either the X or the Y. I don't want to mix like 2 and -1.5, because 2 is X, 1.5 is a Y value. So what you want to look at here is what would be easiest, okay? So if I go with C, all right, I'm dealing with negatives and I'm dealing with decimals. We want to try to avoid that if possible, just because it's easier to make a mistake, okay? If I look at D though, you want to think, all right, would it be better to choose the X's, you think? So 2 and 3, or the Y's, -1.5, -1.5. Hopefully you thought the X values. Remember, if I chose X from D, I have to choose X from D prime. And that's when I'm going to divide to get my scale factor. All right, so remember it's new coordinate divided by old coordinate, or original, however you want to think of that. All right, so my new X coordinate right here is 3. My old X coordinate was 2. Now I divide those. That gives you a scale factor of 1.5 or 1.5. Okay, so I know that was kind of the long way around that, but make sure you're picking the easiest option there, really, okay? All right, 6, dilate the figure using k equals 1/4. State the new coordinates and write the rule used. Okay. So if we're looking at our scale factor is what they're talking about with the k, all right? So I first need to write out my coordinates. So I'm going to put old or original. Those are our old coordinates, okay? So take a second, write down those coordinates. Remember that part of the problem has to be correct or the rest is all wrong. So pause, make sure you can get that. Okay, if you've paused, you should be checking your answer now. So you should have gotten A is -2, -2. B is -2, 2. C is 0, 2. And D is 2, 0. All right, now I'm going to do the new coordinates over here. So they are taking this, and we said the scale factor is 1/4, all right? So that's less than 1, meaning our shape is going to be getting smaller. If it's greater than 1, it gets bigger, okay? So I want to kind of double check that each time. What you are doing now is you're taking each coordinate, so x and y, and multiplying it by that scale factor, because dilation is to multiply, all right, to get your new coordinate. So I'll show you what I mean here. So for example, A is -2 and -2, so that works out well. So I'm going to take -2, and you can do this on your calculator, please. If you're not good with fractions, please do that. So times 1/4. Okay, hopefully this will go quick on this one, but again, to be sure, you can use your calculator. So I can cross cancel those, or you can simplify at the end, either way. Negative times a positive, that's -1/2, -1/2. In this case, the x and y coordinates were the same. They're both -2. So if x is now -1/2, so is y. It's a little hard to graph the halves, but so I'm going to go -1/2, -1/2 there. So that's A prime. Okay, same thing with B prime. Now, good thing here is these 2's are repeated a lot, so -2 again, well, times 1/4 is still -1/2. If I multiply it by 2, the only thing that's going to change is that negative will be positive, so that's just 1/2. All right, and here's a good spot to go ahead and pause and see if you guys can get C and D prime, okay? So if you've paused, you should be checking your answer now. Once you multiplied C out, C prime, you should have got 0, 1/2. And D prime would have given you 1/2, 0. Okay, I'm going to finish plotting these. So -1/2, 1/2 for B. C. Really hard to fit this in because it's so tiny. And then D prime. Okay, and so always reread your question, please. So state the new coordinates, so we did that, and write the rule used. So write our mapping rule. So always start that with x comma y. Since it was a dilation, what I did here was I multiplied each of those by 1/4. So there's a couple ways you could write this. You could write x times 1/4 and y times 1/4. Or, and what I would prefer is, well, x times 1/4, that's the same as 1/4 x, or 1/4 y. So try to do that one, okay? All right, last problem. So dilate the figure using k equals 2. So state the new coordinates and write the rule used. Okay. So start with our old coordinates. So C is -2, 0. Okay, now if I'm finding my new coordinates, we are multiplying each of them by 2, so this is much easier. So like C, I'm going to do -2 times 2, and I'm going to do 0 times 2, which is then gives me C prime as being -4 and 0. Okay. All right, take a minute, pause the video, see if you can get D and E. Okay, if you're now checking your work, you should have gotten D prime as 4, 2, and E prime as 0, -2. And I'm trying to hurry because London is crying, but so lastly, write the rule used. So we have our new coordinates here. So X, Y, always start with that. And then how we were just like this last one. So we were dialing times 2, meaning it should be getting bigger. So I can write it as X times 2, Y times 2, or how I'd prefer it, 2X, 2Y. I did forget to plot these, so let's do that. So 1, 2, 3, 4, 0. That is C prime. D, 4, 2. And E prime. And connect. So on dilations, it should still like look kind of the same shape, just bigger or smaller. So kind of look, if you get something crazy, then all right, it's probably off. Okay, so just double check that. Always redraw, always make sure. Okay. All right, again, if you have any feedback this time, something you think would help, then send me an email, let me know. Hope you guys are doing good. Bye.